For centuries, humans have looked up at the night sky, wondering if we're truly alone in the universe. Among all the places we've explored, there's one moon that stands out as a promising candidate in the search for extraterrestrial life: Europa. One of Jupiter's largest moons, Europa is unique. Unlike many celestial bodies, its surface is made of water ice. Scientists believe that beneath this icy shell lies a vast ocean, an ocean that might contain more water than all the oceans on Earth combined. So why does this matter? Well, water is one of the essential ingredients for life as we know it. Wherever we find water on Earth, we almost always find life, even in some of the most extreme environments. This raises an exciting question. Could there be life beneath Europa's icy surface? NASA has designed a mission to help answer this question. It's called the Europa Clipper. The Europa Clipper mission is scheduled to launch in October 2024 and aims to explore Europa like never before. By closely studying its surface, icy shell, and potential subsurface ocean, scientists hope to gather crucial clues about the moon's potential for life. Now let's break down what the Europa Clipper is, what it's going to do, and why it's such an exciting mission for the future of space exploration. First, let's talk about the journey. Europa is about 390 million miles away from Earth. To get there, the Europa Clipper will use a series of gravity assists essentially. It will slingshot around Mars and Earth to gain the momentum needed to reach Jupiter. This journey will take about 6 years, and the spacecraft is expected to arrive in the Jupiter system around April 2030. Once it arrives, the Clipper won't land on Europa. Instead, it will perform multiple flybys, orbiting Jupiter and passing close to Europa dozens of times. Each flyby will bring it close enough to gather detailed data without exposing the spacecraft to the intense radiation around Jupiter for too long. This approach allows the Clipper to collect high-resolution images and data from a safe distance. So what is it looking for? The Europa Clipper has 3 main goals. The first goal is to confirm the existence and characteristics of Europa's subsurface ocean. We know this ocean likely exists, but we don't know how deep it is, how salty it is, or how it interacts with Europa's icy crust. By measuring Europa's gravitational field and magnetic field, scientists hope to get a better picture of this mysterious ocean. The second goal is to analyze the composition of Europa's surface and its ice shell. Why is this important? Well, if there's any exchange of materials between the surface and the ocean, we might find evidence of organic molecules or other chemicals that could support life. To do this, the Clipper will use various instruments, like spectrometers, to detect and analyze the chemical makeup of Europa's surface. It will even try to spot areas where the ocean might be interacting with the ice, places where the ocean could be pushing through cracks in the ice shell and reaching the surface. The third goal is to understand the structure and geology of Europa's surface. Europa's icy crust is not smooth. It's covered in ridges, fractures, and chaotic terrains, which are thought to result from the movement of the icy shell above the liquid ocean. By mapping these features in high detail, the Europa Clipper will help scientists understand the processes that shape this unique environment and give us insights into the potential for life. One of the most exciting aspects of this mission is the possibility of detecting plumes. Plumes are jets of water vapor that could be erupting from Europa's ocean, shooting up through the ice and into space. If these plumes exist and the Clipper detects them, it could analyze their chemical composition to look for organic molecules or other signs of habitability. This would be the closest we've come to directly sampling the ocean on another world. Now, let's talk about the technology on board the Europa Clipper. This spacecraft is equipped with a suite of powerful instruments, specifically designed to study Europa's environment. For example, it has an ice-penetrating radar that can look beneath the surface to measure the thickness of the ice shell and possibly detect liquid water below. It also has a magnetometer to study Europa's magnetic field. This tool is crucial because the magnetic field can tell us a lot about what's beneath the ice. For example, if the magnetic field shifts in a way that suggests a conductive layer, it could indicate that Europa's ocean is salty, like Earth's oceans. Then, there's a thermal imaging system. This system will look for warm regions on Europa's surface, which could be areas where the ocean is close to the surface, or where heat from below is melting the ice. Warm spots could signal areas of interest, where interactions between the ocean and the ice are occurring. The Europa Clipper also carries a series of cameras and spectrometers. These will provide high-resolution images of Europa's surface, capturing its complex geology in unprecedented detail. The spectrometers, meanwhile, will analyze the chemical composition of the surface, searching for compounds that could hint at biological activity. So why is this mission so important? If the Europa Clipper finds evidence of life-supporting conditions or even traces of organic molecules, it would be a game-changer in the field of astrobiology. Discovering even the most basic forms of life on Europa would show us that life can exist in a broader range of environments than we previously thought possible. This could mean that life is not unique to Earth, but might be common throughout the universe. Imagine what that would mean. For centuries, humans have wondered if we're alone in the cosmos. Finding evidence of life, even microbial life, on a moon orbiting a distant planet would be one of the greatest discoveries in human history. It would change how we see ourselves and our place in the universe. The Europa Clipper mission also has implications beyond Europa. By understanding this moon's geology and potential habitability, scientists will learn more about other icy moons in our solar system, like Enceladus and Titan around Saturn, which also have subsurface oceans. These discoveries could guide future missions and expand the scope of our search for life beyond Earth. So, what comes next? Once the Europa Clipper completes its mission, scientists will analyze the data and hopefully answer the question of whether Europa could support life. If the results are promising, it could pave the way for even more ambitious missions. Imagine a mission that lands on Europa, drills through the ice, and sends a probe down into the ocean to search for life directly. The Europa Clipper mission is a giant leap forward in our exploration of the outer solar system. In the coming years, it will bring us closer to understanding one of our most profound questions: are we alone? And perhaps one day, it will reveal a universe filled with life in places we never expected.